Okay, one of the recent updates to Macs is the use of the new gamepad object, which is a great replacement for the old HI. So I'm going to show you how to use this really quickly to create a very basic synth using the gamepad. So here I've instantiated the gamepad, and it has connected in the console, and it sees my 8-bit DO Pro 2 controller, which is hooked up via Bluetooth. So that's already there, and it likes it. So with gamepad, I'm really only concerned about this leftmost outlet, which is the event message. I'm going to connect that up to an empty message box, and I'll show you why. So if I hit the up button on my gamepad, I get button D-pad up 1 when it's pressed, and when I release it, I get a 0. And that's going to be true for pretty much everything. I'm going to try the right button, and I get right shoulder 1, and then button right shoulder 0 when it's released. So that's really cool. Really useful, and I can use this in a variety of ways for, simple button presses in Macs. However, there is something that you need to be very aware of. Triggers and analog sticks. So the 8-bit DO Pro 2 is very similar to a PlayStation-style controller. It's got 2 analog sticks and 2 analog triggers. And if I press a trigger, so I've got access left trigger, and I have a range of floats from 0 to 1. Similar, if I move the analog stick, I get a range of values that is effectively -1 to +1. It's actually a little bit less than full -1 on some controllers, so I usually just say -1 to +1. So the question is going to be, how are we going to use this? And the answer is, well, we're going to start mapping it. And to map it, we're going to create a comment. And then I'm going to figure out what I want to use. So for this example, I'm just going to use really, really basic. I'm going to do up, down, left, right, and then the 4 buttons as well. So if I press, we'll start with button up. I get this here in the message. And it's always going to have a 0 or a 1 state. So I'm going to copy that, and I'm going to put it in as 0 or 1. Button down, hey, pretty much the same thing, except I just change a couple of values. And you can probably guess at this point it's going to be the same for left and right. So it's always going to be button _ D-pad, the direction, and then a value of 0 or 1 for if it's not pressed, it's a 0, and if it's pressed, it's going to be 1. And that one should be right. Okay, so now let's look at our buttons. This is button B, button A, button Y, and button X, which is exactly how they're labeled on the 8-bit DO Pro 2 controller. So I'm just going to grab button B, and we're going to place that here. Button A, button Y, and last but not least, button X, 0 or 1. And I could go through and I could map out all of these as well. There are different presses for button back, start, for the shoulder buttons. There's other buttons on there as well, including if I push the stick in, I get button right stick or button left stick, and those are just 0 or 1s as well. But we're seeing a lot of other stuff there because, again, yeah, the sticks, if I move them, I just get that floating point value range. So at this point, it is important for me to say, before we go any further, that I am doing this on a Mac. And the Mac values are one thing, and the PC values are probably something totally different. So you do want to specify that you're doing this on a Mac or on a PC so that your users can know what they have to have. Also, be very aware that while this will work with a variety of game controllers, I've successfully used this with PlayStation controllers, Xbox controllers, Hitbox controllers, a lot of stuff. But there is one that it will not work with, which is the Nintendo Joy-Cons. And for whatever reason, you can use one or you can use the other, but you cannot use both of them simultaneously. That's just a function of how Nintendo has apparently implemented the Bluetooth on that. But let's start creating some interesting stuff with this. So what I'm going to do is I'm going to use the route object, and I'm going to basically make this into a really simple scale controller. So I am a big fan of the classic Konami code, which if you grew up in the 80s and 90s, you probably know by heart. But if you don't, it's up, up, down, down, left, right, BA, start. So in the order, that would be up, down, left, right, B, A. And then at that point, well, we are starting to get a little bit away from that. So I still have an X and a Y. So what I'm going to do is I'm going to mirror the up, down, left, right. I'm going to use that for effectively C, D, E, F. Then I'm going to use X, B, Y, A to modify that code so that it's mirrored on the buttons and on the D-pad. So to do this, what I'm going to do is I'm going to use route. I'm going to look for specific button presses. So I'm going to do button underscore D-pad underscore up. And that's going to be the first thing that it looks for. And I'm going to do the same thing with down. And now we can test and see if that's working by inserting a couple of bangs and seeing what happens. When I press button up, we get a bang that matches the first output because button D-pad up is our first argument. And if I hit right, you can see up here in the message that I'm pressing right, but nothing comes out of route. If I press down, we get one out of the second. So yeah, it's working. So now I'm going to just continue on copying the button D-pad underscore, and then I'm just going to change the value at the end. So this will be left, this will be right, and then it's going to be button underscore, without the parentheses, and that will be button X, followed by button B, followed by button Y, and then finally button A. And again, I can hook up all sorts of bangs to check this, and let's see if it does in fact work for all of these. And keep in mind that the final output of route is the dump out. So if something doesn't match, that's where it's going to go. So going from left to right, I should have up, and I do, down, left, right, X, B, Y, and A. Now, if you've been watching the bangs, you'll notice that you're probably seeing two bangs every time I press a button. So there's button B, I'm holding it down, and as soon as I release it, we get a second bang. So this is reporting a change in state here. And that's potentially something I might not want. So if I want it to, for example, only send a single note out, then I'm going to have to be a little bit careful with how I do this. I'm going to have to filter some things a little bit. But for our purposes, we're just going to use this for a very, very simple monophonic synthesizer. So what I'm going to do is I'm going to create a couple of little messages that trigger whenever it receives a bang. So for MIDI, we're going to do 60. We're going to hook that up. And then we're going to output that to something else. But we could actually make this a little bit more functional. What we can do is we can do, say, cell 1. And if we do that, it's only going to work when it receives a message of 1. So it's going to be button, D-pad, up, and then a value of 1, and then it will trigger. But it won't trigger on the release. And I can show you that really quickly here. So I'm holding up button 1, but when I release it, nothing. So that's really useful. So we're going to use that, and then I'm going to do a message. We'll do 60 and then a velocity of 100. And then I'm going to send that to a object down here. We're going to have an EZ DAC and a good old-fashioned live.gain to control the amplitude. But before we do that, we need to convert this MIDI information of pitch and velocity into something we could actually use. So what I'm going to do is I'm going to create a very, very basic ADSR object. We're going to give it a ramp up time of 20 milliseconds, a decay time of 25, sustain of 0.75, and a release of 100 milliseconds. Then I'm going to connect that to a multiply audio object, like so. And here I now have the ability to create sound. But before I do that, I need to unpack these values, and I need to do a little bit of actual sound creation. So what we're going to do is we're going to do a divide object by 127 with a decimal point, and that will take our velocity and effectively convert it into a floating point range between 0 and 1, which is what ADSR is expecting. Then over here, let's do some sound generation. So I need to convert MIDI into frequency, so I'm going to use M to F. Connect that up, and then we need some sort of oscillator. I'm kind of feeling in the mood for a sawtooth, so I'm going to use saw. I'm going to initialize that with an argument of 0 for the frequency. And at this point, this basically should work. So let's turn it on, take the volume down a little bit, and see if it gives me middle C when I press the up button. Okay, and it does. However, there is a small problem. If you're listening to this, you have probably heard that it's droning on, and it's ignoring my ADSR. So what we need to do with that is we need to factor in a way that this is going to turn on and turn off. Because I could, create another message box here and duplicate that and make this one 60 and a velocity of 0. Then connect that to the output of select. And we're going to have the note droning again. And that will work. That's one way to do it. But it might be a little bit more interesting to have a slightly more elegant way of doing that. But that's going to be coming on in later videos. For now, what we can do is we can encapsulate this And to do that, I'm going to select all of these, and then I'm going to hit Command-Shift-E for encapsulate. And I'm going to give it a note name. It's P for subpatch, so we're going to call it note, can't type, note C. And there we go. And this is effectively going to give us the note generator that we've just created. So if I double click this, we can see that it's got all of that in presentation mode, which is because I hit Command-Shift-P. We can take that out of presentation. But it's unpacking, and it's looking at what it's received for the MIDI information, and then it's sending that to M2F and to the ADSR, and then it's sending the output audio to live.gain. So in fact, this doesn't even need to be note C. This is our note generator. So we can actually copy this and paste it. So we'll just call it notes. And then we can hook it up to everything else here and get a really simple synth. So if I'm going up the scale from C to D, then my next note is going to be 62. So I'm just going to change these MIDI note values, and then I'm going to connect that up. So now up should be middle C, and down should be D. And so far, so good. So now I'll duplicate that. And this will be E, which is going to be 64. And I do have to change for both the on and the off message. Then F would be our next note, and that should be 65. Okay, and now I just need one more copy and paste. There we go. Kind of hard to grab it with the trackpad from time to time, but we can move it over. And now we have G, which is 67. A, which is 69. B natural, which is going to be 71. And C an octave up, which is 72. So let's connect those up, and this should be button X, followed by B, followed by Y, and then ending with button A. And if I have done it correctly, I have the dump output of route unconnected. So that looks like it's good. So I'm just going to connect everything up to live.gain. And let's give it a test and see if we get a nice C major scale. Cool. It works. And I can play, some basic harmony. But it's nothing that I would really want to write home about. But that is it for gamepad. Really, really useful object, really good. But again, keep in mind there's limitations. You do have to have different values for if you're on a Mac versus on a PC. And of course, if you are using any type of keyboard controller or hitbox or gamepad, you'll want to specify what you're using for your users so that they have the same thing, because obviously different controllers have different implementations, and you really don't want to have lots of weird questions popping up later on a couple years after you've performed the piece.